Hi, welcome to Chapter 12 Solutions. Today's tip is to apologize to any of your loved ones you've been rude to over the course of your GRE preparation. That includes your parents and your partner, your coworkers and friends, and even your dog. After all, it's not their fault you decided to go to grad school. Or is it? Okay, we're going to get started with number one. Number one asks us to find the value of k that would make these two lines perpendicular. So remember, in order to be perpendicular, the slopes of the two lines have to be the negative reciprocal of each other, or the product of the slopes has to be -1. Okay, so keeping that in mind, this is the slope-intercept form of an equation where m is the slope. So if we can rewrite these two equations into this form, we can compare our two slopes. Okay, so this first one, 3x plus 2y equals 12. Can actually get rid of this. I want to get y by itself. So I'm going to subtract 3x from both sides. And then I'll get 2y equals -3x plus 12. And then I'm going to divide through by 2, because we want the equation to have y by itself. So we get y equals -3/2 x plus 6. Our slope is -3/2. Now I'm going to step over here and do the same for this second equation. Okay, so that is 4x minus ky equals 4. We're going to subtract 4x from both sides. We're going to get -ky equals -4x plus 4, and finally we'll divide through by -k to get the x by itself. Okay, now what we're interested in here is just this slope. Since we have a negative divided by a negative, that is just a positive. Okay, so we want to compare -3/2 to 4 over k, and one needs to be the negative reciprocal of the other. So if this slope is -3/2, its negative reciprocal is +2/3. So +2/3 is what 4 over k must be. So we can cross multiply here. We get 2k equals 12, and then k equals 6. So k has to be 6, so the answer choice is E. Number two. For number two, we're asked which of the following ordered pairs, sorry, I have that on there twice. Which of the following ordered pairs is a solution to both of these equations? So you have two ways of solving this that come to mind. One, you can plug in each one of these ordered pairs into both of these equations and make sure that they come up with true statements for both. You might imagine that that's a little bit time consuming. The other thing you can do is solve for x and y here, and if you solve for x and y, then you won't have to test all of your answer choices. Okay? If you do decide to go with that first method of plugging in, you would plug in the first coordinate for x and the matching y coordinate for y to see if it works out. Okay? But instead, we're going to go ahead and try to solve for x and solve for y. So in this case, there's no way where we can simply add or subtract our equations to cancel out one of the variables. So the first thing you need to do is decide which variable you would like to cancel out. So to me, it looks easier to cancel out the y, because if I multiply this second equation by 8 rather, if I subtract the two equations, the y's will cancel out. Okay? So let me show you what I mean there. If we multiply through by 8, this is going to become a -8y. Or we can multiply through by -8 to make it a +8y. It doesn't matter. Okay, so I'm going to recopy the first equation as is. And then I'm going to distribute this 8 throughout the equation. So 8 times 1/4 is 2. If you're not sure about that, put this over 1, multiply your numerators over your denominators. So you get 2x, then you get -8y equals 16. And at this point you realize, hey, I have the exact same equation. So if I subtract, I get that 0 equals 0. If I have the exact same equation, or if I decide to work it out to get 0 equals 0, that means any ordered pair that works for the first equation will work for the second equation. So that's why the answer choices A, B, C, and D all work. If you plug in this first ordered pair here, so for example, I plug in 0 here and -2 here, I get 0 minus 8 times -2. Well, 8 times -2 is -16. Minus -16 is +16. And it's going to work like that for all of these, and therefore the answer is A, B, C, and D. Number 3. Number 3 asks us for the midpoint of the line segment whose endpoints lie on the parabola. So while this red line is actually a full line, the part of a line can be a line segment, so from here to here. So we want to find the midpoint of this line, so we have to know what the two endpoints are. So it's 0, -2 for this endpoint, and then this endpoint is 1, 2, 3, 4, 5 over and 3 up, so that's 5, 3. Okay? Now, the formula for midpoint is just the average of your x-coordinates for your new x-coordinate and the average of your y-coordinates to get the midpoint of your the y-coordinate of your midpoint. Okay, so the midpoint should be somewhere in here. X1 plus x2 is 0 plus 5, which is just 5, divided by 2. And then y1 plus y2 is -2 plus 3, which is 1, divided by 2. So we get 5 halves, 1 half, and that is 2.5, 0.5. because this is the form that our answer choice is in. So number 3 is D. Number 4. Number 4 asks us for the length of this line segment. So it's the same line segment as in number 3. And to find the length of a segment, you need the distance formula, because distance and length are the same. So here we need to find the change in our x-coordinates. It doesn't matter which coordinate you assign as x2 and which one you assign as x1. If I decide that this is x2, however, it does matter that this, if I decide that this one is x2, it does matter that this one is y2. Okay? If I decide that this one is x2, then this one is y2. It has to go together. So, your x's and your y's. x2 minus x1. If I decide that this is x2, I'm going to do 0 minus 5. I'll actually even label them just to make it really clear. So x2, y2, and this will be x1, y1. Okay, so for x2 minus x1, I'm going to do 0 minus 5, which is -5, and then I have to square it, plus the change in my y's. That's -2 minus 3. So that's going to be -5 squared. And then I'm going to take the square root of that. So the square root of that is, first you have to simplify the inside, which is 25 plus 25. So that is 50. And I need the square root of 50, and we are doing it to the closest number. So the square root of 50 is approximately 7, because the square root of 49 is 7, and this is the square root of 50. Or you can just put it into your calculator, and you'll find that the answer is A. Number 5, here we're asked to find a slope of a line that is perpendicular to the given line. So in order to find a line that's perpendicular to this line, we have to find a line that has the negative reciprocal of the slope of this line, which of course means we first have to find the slope of this given line. So to find the slope, there are two ways we can do it. Since the line is graphed, we can count the rise over the run. The rise is how far up or down you're going, and your run is how far left or right you're going. So if you're going up, your rise is positive. If you're going down, your rise is negative. If you're going to the right, your run is positive, so it follows along the positive side of the x-axis. And if your run is negative, you're going to the left. Okay? The other way you can do it is find the change in your y-coordinates over the change in your x-coordinates. So both of those ways will work. So let's start off with this one, the rise over the run from one point to another. So you're going up 1, 2, 3, 4, 5, and then you're going over 1, 2, 3, 4, 5. So your rise and your run are both 5, meaning your slope is 1. If you had done the change in your y coordinates, you could have said 3 minus negative 2, which is like 3 plus 2, and then 5 minus 0. So either way, you're going to get 1 or 5 over 5. Okay? So the slope of your new line has to be the negative reciprocal of this. Well, the reciprocal of 1 is just 1, because this 1 is over 1. If we flip it, it's still over 1. And we want the negative reciprocal, so that's simply negative 1. So the answer is A for number 5. Number 6. For number 6, we're asked that if the original parabola had its vertex at the origin, what is the formula for the new parabola? Or what is the equation, rather, for the new parabola? So in other words, how has it been shifted? So this is your vertex. Your vertex was originally right here. So how did we shift it over? So before we cover this, I just want to do a reminder. If f of x is your original equation, if you add c to it, so if you add a positive number to it, you are shifting it horizontally to the left. If you subtract a positive number from it, you are shifting it to the right. So it's actually, in that case, maybe the reverse of your intuition. Because if this is positive, you're shifting it in the negative direction. And if this is negative, you're shifting it in the positive direction. So negative means you go to the right. Then this number out here tells you if you're shifting it up or down. So, and how many units. So let's say this D was a positive 3. It means you would shift this up 3 units. So if your vertex was here, you would shift it up 3 units. If this was minus that number, like minus 3, you would shift it down 3 units. Okay? So what we have to look out for here is how many units we've shifted it over. So first we want to check and make sure that we see what the vertex is. So it's 2 over and 1, 2, 3, 4, 5, 6 down. So it's at the point 2, negative 6. It's been shifted over 2 to the right. So remember, a horizontal shift is going to be a shift within these parentheses. So f of x, we shifted it to the right, so it's going to be minus 2, because we shifted it to the right 2 units. And then we shifted it down 6 units. So it's going to be minus 6. And this is the new equation of the function. So the answer to 6 is B. Number 7. Number 7, we're given 2 functions. F of x equals x cubed, and g of x is equal to the square root of f of x. So you see that the function g of x is actually based on what f of x is. Okay? So whatever f of x is, we have to take the square root. Of course, f of x depends on what x is. So we're asked for g of x when x is 1/4. Okay? So that means our input is 1/4. So really what the question is asking us is, what is g of 1/4? Or what is g when x is 1/4? So if we plug in a 1/4 here, that means we plug in 1/4 wherever we see an x across this line. So g of 1/4 is equal to the square root of f of 1/4. Perfect. Now all we have to do is figure out what f of 1/4 is. Well, 1/4 is also our input for function f. So we simply plug the 1/4 in here. So f of 1/4, so if we're substituting 1/4 in for x, we have to substitute the 1/4 in here as well. F of 1/4 is equal to 1/4 cubed. 1/4 cubed is 1/4 times 1/4, which is 1/16, times another 1/4, which is 1/64. So f of 1/4 is equal to 1/64, and we simply plug that in here. So we want the square root of 1/64 to find out what g of 1/4 is. So g of 1/4 is equal to the square root of f of 1/4, which is 1/64, and the square root of 1/64 is simply 1/8. Because we have to take the square root of the numerator, which is 1, and the square root of the denominator, which is 8. So the answer for number 7 is 1/8. That concludes Chapter 12 solutions. Make sure you go to the official guide and do the related problems, and then come back and see us for Chapter 13. Good luck.